my dear viewers, welcome once again to this online class. In today's class, we want to look at another question from WAEC past question. And this question is coming from set theory. Now, the information says if the set of A are the what? The multiples of 2. So the elements of set A are multiples of 2. The elements of set B are multiples of 3. The elements for set C are factors of 6. And all these, both set A, set B, set C, are subsets of universal. And the members or elements of universal are 1, that is between 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, we are now have to find A complement intersection B complement intersection C complement. So this side is pronounced what? Complement. So A, this is known as A complement. Now, let's start. The first thing we are going to do is to write the elements of set A. And the elements of set A says multiples of 2. So what are the multiples of 2? There are 2, 4, 6, and so on. But don't forget, set A is a subset of universal set. That means whatever you want to list as the elements of set A must not exceed what is in the universal set. That means it must not exceed this step. Alright, so I'm going to have multiples of 2. I'm going to have 2, 4, 6, 8, 10. So I'm going to stop at 10 because it's a subset of what? Universal set. And universal set is between 1 to 10. Alright, moving on to set B. Set B, the elements of set B are multiples of 3. What are the multiples of 3? I have 3, 6, 9. I'm not going to write 12 because B is also a subset of universal sets. So as universal set is between 1 to 10. Okay, good. Another one, let's look at the elements of set C. The elements of set C are factors of 6. Factors of 6. What are the factors of 6? 1, 2, 3, and 6. These are the factors of 6 that are subsets of universal sets. Now, the middle question says we should find A complement intersection B complement intersection C complement. So definitely we need to find A complement first. A complement. What do we mean by A complements? A complements are the members of universal sets that are not in A. Once again, members of universal sets that are not in A. Okay, in that case, let me first write out my universal sets. Universal sets. Let me put that way here. Universal sets. That should be the first thing you have to do. So members of universal sets are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the members of universal sets. Now, so A complements will now be members of universal sets that are not in A. Alright, in that case, I'm going to have 1 is in universal, is not in A, so 1 will be here. 3 is in universal, is not in A, so 3 will be included. 5 also, 7, and 9. These elements are in universal. They are universal sets, but they are not in A, so they are referred to as A complements. Moving on to B complements, because we need that also before we can find this. So B complements, these are the elements of universal sets that are not in what? That are not in B. So in that case, I'm going to have 1, 2, 4, 5, 7, 8, and 10. Okay, then C complement. These are the members of universal that are not in C. So in that case, I'm going to have 4, 5, 7, 8, 9, and 10. So these are the members of A complement, B complement, and C complement. Now the question now says we should find A complement intersection B complement intersection C complement. What this simply means is that we should find the common elements, the element that is common to both A complement, B complement, C complement. Once again, this simply means that we should find the elements or the members that are common to both A complement, B complement, and C complement. So let's look at the elements that are common to both of them. Okay, here now you can see that 5 is common, 5 is here, 5 is here, 5 is here. So 5. I'm going to pick 5. Now another number, 7 is here, 7 is here, 7 is here. So I'm going to pick 7. Do we have any other numbers? No. So in that case, A complement intersection, B complement intersection, C complement is equals to set of what? Is equals to 5 and 7. Only 5 and 7. Only 5 and 7. So that is going to be our final answer. Thanks for watching, guys.